In the grand, silent theater of the cosmos, where filaments of incandescent gas stretch for a billion light-years and galaxies cluster like dewdrops on an infinite, invisible web, there exists an illusion of uniformity. From our lonely perch, we gaze outward and perceive a universe governed by elegant, unbreakable laws, a place where matter, though clumped and scattered by gravity's patient hand, is ultimately distributed with a reassuring evenness. This cosmic web, pulsing with the light of 100 billion galaxies, each 100 billion stars strong, seems to hum with a predictable, rhythmic life. It is a tapestry woven from light and gravity, dark matter and dark energy, a masterpiece of cosmic order. But nestled within this breathtaking panorama, hidden in the deep southern sky, lies a region that defies this order. It is a place that whispers of a different set of rules, a story written in a language we are only beginning to comprehend. Behind the glittering jewels of a distant galactic gathering known as Cluster 14, there is a wound in the fabric of reality. It is a patch of sky that is not merely dark, but profoundly, unnervingly empty. It is a zone of impossible cold, a silence that screams louder than a supernova. Astronomers have pointed their most powerful instruments at this void, listening for the faintest echoes of creation, and have heard back only a chilling, profound nothingness. This is not the gentle, life-giving darkness between the stars. This is an aggressive, encroaching emptiness, a blight on the cosmic map that suggests the universe is neither as simple nor as safe as we once believed. It is a riddle that challenges the very foundations of our cosmological models, a void that carries the weight of a primordial secret. What could carve such a colossal hole in the universe? What ancient event, what unimaginable force, could leave behind a scar so vast it drains the very heat from the oldest light in existence? To understand the fear that this void inspires, we must journey to the edge of space and time, back to the dawn of creation itself, and confront the terrifying possibility that our universe is not alone. We invite you to gaze with us into this abyss, to peel back the layers of light and shadow, and to ask the question that haunts the halls of astronomy: what is lurking in the cold void behind Cluster 14? Now, let's begin. Music begins, slow and resonant. The story of this cosmic anomaly does not begin with the discovery of the void itself, but with a messenger that has traveled for 138 billion years to reach us. This messenger is the cosmic microwave background, the CMB, the universe's first light. It is the afterglow of the Big Bang, a faint, pervasive radiation that bathes the entire cosmos in a cool, gentle hum. Released when the universe was just a toddler, a mere 380,000 years old, this light carries the fossilized imprint of the primordial cosmos. It is a baby picture of the universe, and in it, we expected to see the seeds of all future structure. For decades, our instruments confirmed this picture with astonishing precision. The CMB was almost perfectly uniform, its temperature a steady 2,725 degrees above absolute zero, no matter which direction we looked. The tiny, 1 part in 100,000 fluctuations in this temperature were the legendary seeds, the slightly denser regions that gravity would later sculpt into the galaxies and clusters we see today. It was a triumphant confirmation of our theories, a map that showed us where we came from. But in 2004, a new map, crafted by the Wilkinson Microwave Anisotropy Probe, revealed something deeply unsettling. In the direction of the constellation Eridanus, there was a patch of the sky that was colder than it had any right to be. It wasn't a subtle fluctuation, it was a colossal, anomalous bruise on the infant universe. This region, which would come to be known as the CMB cold spot, was vast, stretching over 1 billion light-years across. The light arriving from this direction was significantly colder than its surroundings, a deviation so statistically improbable it was like finding a frozen lake in the middle of a desert. The ancient light, our most trusted messenger from the dawn of time, was telling us that something was fundamentally wrong. This was not merely an absence of heat, it was an active deficit, a drain of energy that our standard model of cosmology could not explain. The probability of such a large, cold region occurring by random chance was vanishingly small, less than 1 in 1,000. It was a statistical impossibility that stared back at us from the edge of time, a ghost in the machine of creation. Scientists scrambled for an explanation. Perhaps it was a systematic error in the satellite's instruments, a flaw in the data analysis. But as other telescopes, like the Planck satellite, turned their gaze upon it, the cold spot remained. It was real. It was a permanent feature of our sky, a chilling testament to an unknown physical process. The light from this direction had been tampered with on its long journey to Earth. Something had leached its energy, leaving behind a cold shadow. The fear began to set in not because of what was there, but because of what this coldness implied. It was a signpost pointing to a profound gap in our knowledge, a hint that the universe's history contained chapters far darker and more violent than we had ever dared to imagine. The uniform, predictable cosmos had just developed a crack, and through it, we could glimpse a terrifying, unknown abyss. The immediate and most logical suspect was, of course, an absence of matter. The journey of a photon from the edge of the observable universe to our telescopes is not an uninterrupted one. It is a cosmic odyssey through a landscape sculpted by gravity. As light enters a region dense with matter, like a supercluster of galaxies, it gains energy, falling into the gravitational well. This is a process known as blue shifting. As it climbs back out of that well, it loses the energy it gained, redshifting back to its original state. However, the universe is not static, it is expanding, and this expansion is accelerating due to dark energy. This means that by the time the photon climbs out of the gravitational well, the well itself has become shallower because the matter within it has spread out. The photon, therefore, doesn't lose all the energy it gained upon entry. The net result is a tiny increase in its energy, making that patch of the CMB appear slightly hotter. Conversely, if a photon travels through a vast region with very little matter, a void, the opposite happens. It loses energy as it enters the anti-well and doesn't fully regain it upon exiting, because the void has stretched and become even more empty during its transit. This phenomenon, the integrated Sachs-Wolf effect, should create a cold spot in the CMB. The puzzle of the cold spot seemed to have a simple solution: there must be a colossal void, an immense bubble of nothingness, lying between us and that patch of the ancient sky. An astronomical investigation was launched. For years, telescopes meticulously surveyed that sector of the heavens, charting the positions of galaxies in 3 dimensions. Using the principle of redshift, where the light from distant galaxies is stretched to redder wavelengths by the expansion of space, astronomers began to build a map of this unseen territory. They were not just taking a picture, they were performing cosmic cartography, peering deeper and deeper into the dark. The work was painstaking. They measured the light from hundreds of thousands of galaxies, calculating their distances to see if they would thin out, to see if the vibrant cosmic web would simply stop. And it did. As their maps pushed further, reaching hundreds of millions of light-years from Earth, they found it. The rich tapestry of galactic filaments and clusters began to fray. The light from distant quasars, which should have been intercepted and absorbed by intervening galaxies, streamed through unimpeded. They had discovered one of the largest structures ever identified by humanity, the Eridanus supervoid. It was a breathtaking chasm in the cosmos, 1 billion light-years in diameter, a desert of staggering emptiness. Inside this void, the density of matter was significantly lower than the cosmic average. Where there should have been thousands of galaxies, there were only a handful, lonely islands in a vast ocean of desolation. It was a chamber of silence, a place where the universe seemed to be holding its breath. The discovery was a monumental achievement, a testament to human ingenuity. They had found the void. They had found the source of the cold spot. The mystery, it seemed, was solved. But this feeling of triumph was short-lived. A new, more profound dread was about to replace it. The numbers were not adding up. The void was there, just as predicted. But it was not enough. The laws of physics are a comfort. They provide a framework, a set of rules that govern the cosmic dance of matter and energy. The integrated Sachs-Wolf effect was one such rule, a clear and predictable consequence of general relativity and an expanding universe. It gave scientists a tool to calculate exactly how cold a patch of the CMB should be, given the size and emptiness of a void it passes through. When they applied this tool to the Eridanus supervoid, the comfort of predictability shattered. The supervoid was immense, a truly colossal structure capable of leaving a significant imprint on the CMB. According to their calculations, it should indeed produce a cold spot. The models were clear: a void of this magnitude would cool the ancient light passing through it, creating a noticeable depression in the temperature map of the early universe. But when they compared the calculated temperature drop with the one they had actually observed, there was a terrifying discrepancy. The Eridanus supervoid could only account for a fraction of the coldness of the CMB cold spot. The observed temperature anomaly was several times colder, several times more extreme, than the largest void ever discovered could possibly explain. It was as if they had found a footprint in the sand and, upon measuring it, realized the creature that made it was impossibly large, far larger than any known animal. The void was the footprint, but the creature that had left the chilling mark on the CMB remained a ghost. This was the moment the mystery deepened into genuine fear. It was no longer a simple puzzle of cosmic geography. It was a direct confrontation with the limits of our understanding. The standard model of cosmology, the elegant edifice of theory built over a century of observation and intellectual struggle, had failed its test. The very theory that predicted the CMB, that explained the expansion of the universe and the formation of galaxies, could not explain this one patch of sky. The discrepancy suggested that either our understanding of gravity on cosmic scales was flawed, or some other, unknown physical phenomenon was at play. A new, more exotic force was draining energy from the universe's oldest light, a force that left no other trace. The Eridanus supervoid was no longer the culprit, it was merely an accomplice, or perhaps just a bystander at the scene of a much greater cosmic crime. The emptiness itself was not the monster. The monster was something else entirely, something that used the emptiness as its lair. The fear among astronomers became palpable, a quiet unease that spread through the community. They were staring at a piece of evidence that pointed towards a universe far stranger than they had imagined. The cold spot was not just a cold spot anymore. It was a portal, a window into a new and unnerving physics that operated on scales beyond our comprehension. The void behind Cluster 14 had ceased to be a place on a map and had become a symbol of our own ignorance, a dark mirror reflecting the vastness of what we do not know. When the known laws of nature fail so spectacularly, the mind must venture into the wilderness of the unknown. It must be willing to entertain ideas that border on the heretical, to question the very bedrock of its assumptions. With the integrated Sachs-Wolf effect falling short, cosmologists were forced to abandon the comfortable and explore the bizarre. The first port of call was the universe's infancy, a time of unimaginable energy and violence. In the first fractions of a second after the Big Bang, the universe is thought to have undergone several phase transitions, moments when the fundamental forces of nature separated from a single, unified force. These transitions are analogous to water freezing into ice. When water freezes, imperfections can form in the crystal structure, cracks and boundaries known as topological defects. Some theories proposed that the early universe, as it cooled and froze into its current state, could have created similar defects, but not in a crystal of ice. These would be defects in the fabric of spacetime itself. One such hypothetical defect is known as a cosmic texture. Unlike a point-like magnetic monopole or a line-like cosmic string, a texture would be a complex, tangled knot of energy left over from a primordial symmetry-breaking event. These textures, if they existed, would be unstable. As the universe expanded, they would eventually unwind and collapse in on themselves, releasing a tremendous burst of energy and warping spacetime in their wake. A collapsing texture would, for a brief moment, cause space to rapidly expand outward from its center and then contract. A photon from the CMB passing through such an event would be profoundly affected. As it traveled through the expanding phase, its wavelength would be stretched, causing it to lose energy and become colder. This effect would be far more powerful than the gentle energy drain from a supervoid. It would be a violent, one-time event that could create a cold signature of the exact magnitude observed in the CMB cold spot. This theory had a chilling elegance. The cold spot was not a feature of the present-day universe, like a void, but a fossil. It was the ghostly afterimage of a cataclysmic event that occurred hundreds of thousands of years after the Big Bang, a scar left on the firmament by the unwinding of spacetime itself. In this scenario, the Eridanus supervoid is a cosmic coincidence, a separate structure that just happens to lie in the same line of sight. The real cause is an invisible wound, a memory of a time when the rules of physics were still settling, when the universe was still wild and untamed. It suggests that the cosmos is not a perfectly smooth crystal, but one containing flaws, ancient and powerful echoes of its own violent birth. This idea, while compelling, remains on the fringe. We have no other evidence that cosmic textures exist. They are ghosts conjured by theoretical physics to explain a haunting observation. To accept this theory is to accept that the universe bears scars from processes we cannot see and can barely imagine, a universe where spacetime itself can become tangled and torn. The fear, then, transforms. It is no longer a fear of emptiness, but a fear of the universe's own volatile past, a past that has left a permanent, cold wound on our sky. If the notion of a flaw in spacetime feels unsettling, the next candidate for the cold spot's origin is an idea that shatters our entire conception of reality. It is a theory so profound and audacious that it relegates our entire observable universe to the status of a single grain of sand on an infinite shore. This is the multiverse hypothesis. The theory posits that our universe is not unique. Instead, it is but one bubble in a vast, endlessly frothing sea of other universes, a cosmic foam of countless realities, each with potentially different physical laws, different constants of nature, perhaps even different dimensions. In this breathtaking vision, the Big Bang was not the beginning of everything, but simply the moment our particular bubble universe inflated, separating itself from the chaotic metaverse. These bubble universes, according to the theory of eternal inflation, are constantly being born. And like bubbles in a boiling pot, they can drift, expand, and, sometimes, collide. The multiverse hypothesis offers a truly dramatic explanation for the cold spot. It proposes that in its earliest infancy, when our universe was still a searingly hot, infinitesimally small point of quantum energy, it was struck. It had a close encounter, a cosmic fender-bender, with another bubble universe. This would not have been an explosion in the conventional sense. It would have been a collision of two entire realities. The impact would have sent a shockwave of gravitational energy rippling through our young cosmos, a physical bruise on the nascent fabric of spacetime. This collision would have pushed energy and matter away from the point of impact, creating a quantum perturbation on a scale far larger than any standard inflationary fluctuation. This primordial disturbance would then be magnified by the exponential expansion of our universe, stretching it across 1 billion light-years. The result, 138 billion years later, would be a vast region of space that is subtly, yet fundamentally, different. It would manifest as a massive supervoid, and more importantly, it would leave a permanent, cold imprint on the cosmic microwave background. The cold spot, in this telling, is the point of contact. It is the lasting scar from an interuniversal collision. It is evidence that we have touched another world, another existence. This theory elegantly explains the two key pieces of the puzzle, the existence of the Eridanus supervoid and the excessive coldness of the CMB spot. The void isn't a coincidence, it's a direct, physical consequence of the collision, the place where matter was gravitationally shoved aside. The extreme coldness isn't from the integrated Sachs-Wolf effect alone, it's the lingering thermal shadow of the impact itself. The implications are staggering. It would mean that the most anomalous feature in our sky is the only piece of empirical evidence we have for the existence of other universes. It turns the cold spot from a local mystery into a window onto the infinite. But it is a terrifying window. It suggests a cosmos that is not a serene, isolated expanse, but a potentially violent and crowded arena where entire realities can crash together. What would have happened if the collision had been more direct? Would our universe have been annihilated, its physical laws rewritten? The fear inspired by this idea is one of cosmic vulnerability. It reframes our existence not as the central drama of creation, but as a fragile, contingent event, one bubble in a chaotic ocean, lucky to have survived a brush with an unknown neighbor. The void behind Cluster 14, in this light, is a reminder that just outside the walls of our perception, other worlds may be lurking. To truly grapple with the nature of the void, we must zoom in, past the galaxies, past the stars, past the very atoms themselves, and into the realm of the quantum. What is nothing? In our classical intuition, a void is simply an absence. It is a container with its contents removed. But modern physics tells us that there is no such thing as true, absolute emptiness. Even in the darkest, coldest, most isolated pocket of the cosmos, space itself is alive. It seethes with a roiling, effervescent energy known as the quantum foam. In this realm, the law of conservation of energy can be briefly suspended. Pairs of virtual particles and antiparticles spontaneously erupt into existence from nothing, exist for a fleeting moment, and then annihilate each other in a tiny puff of energy. This constant, ghostly dance is happening everywhere, at every moment. The vacuum has energy. This vacuum energy is what we believe drives the accelerating expansion of the universe, the force we call dark energy. The Eridanus supervoid, therefore, is not truly empty. It is a sea of this quantum activity, just one with a much lower than average density of matter and radiation. But what if the void is more than just a lack of matter? What if it is a region where the vacuum energy itself is different? Some theories suggest that the value of this fundamental energy is not a universal constant, but can vary from place to place. Perhaps the supervoid is a domain where the vacuum energy is lower than in the rest of our universe. A region with a lower vacuum energy would have a different gravitational property. It would not just be a passive emptiness that matter avoids, it would be an active repulsor. It would gravitationally push matter and energy away from it, effectively acting as an anti-gravity well. This would explain why the void is so empty. It has actively expelled matter over billions of years. It would also provide a new mechanism to cool the CMB photons. As light passes through this region of altered physics, it would interact with this unique gravitational field in a way that drains more energy than standard models predict. The cold spot would be a direct measurement of a place where the fundamental properties of the cosmos are different. This line of inquiry leads to an even more profound and disquieting possibility. If the vacuum energy can be different there, what about other fundamental constants? The speed of light, the charge of an electron, the strength of the gravitational force, we assume these are immutable, the same everywhere and for all time. The void challenges this assumption. It could be a glimpse into a different kind of physical reality, a bubble of alien physics existing within our own universe. The fear, then, becomes one of fundamental instability. It suggests that the laws of nature that make our existence possible are not as solid as we thought. They might be local bylaws, contingent on our specific address in the cosmos. The void becomes a place where the familiar rules break down, a zone of ontological uncertainty. It is not an absence of things, but the presence of a different kind of being, a state of existence governed by a logic we cannot access. It is the ultimate unknown, not just a place without matter, but a place without the familiar reassurances of our own reality. For centuries, our view of the cosmos was one of poles. Gravity was the great sculptor, the shepherd of the galaxies, a force that always attracted, always gathered things together. We see its work everywhere, in the dance of planets around a star, in the swirling arms of a spiral galaxy, in the majestic congregation of clusters. Our own Milky Way galaxy is not exempt from this cosmic pole. We, along with our entire local group of galaxies, are hurtling through space at over 2 million kilometers per hour. For decades, the destination of this mysterious journey was unknown. We were being pulled by something immense, something that lay beyond our view, hidden by the dust and stars of our own galactic plane. This unseen gravitational source was dubbed the Great Attractor. More recent studies have revealed an even larger structure beyond it, the Shapley supercluster, a titanic collection of galaxies exerting a powerful gravitational pull on a vast swath of the universe, including us. This is the cosmic story we are used to: matter clumps together, and we are pulled toward the largest clumps. But every force in nature has its counterpart. For every action, there is an equal and opposite reaction. What if the cosmic web is shaped not only by attraction but also by repulsion? What if our motion through the universe is not just a journey toward something, but also a journey away from something else? This is where the void behind Cluster 14 re-enters the narrative, but in a new and terrifying role. Some cosmologists now propose that the Eridanus supervoid is not just a passive hole, but an active participant in the cosmic flow. They theorize it may be a cosmic repulsor, a center of anti-gravity pushing us away. In this model, the universe is a dynamic landscape of peaks and valleys. The great attractors are the peaks, their gravitational pull dragging galaxies toward them. The great voids are the valleys, vast basins of negative gravitational influence that actively shove galaxies away. Our Milky Way's velocity, then, is the net result of this cosmic push and pull. We are being drawn toward the Shapley supercluster and simultaneously pushed from behind by the Eridanus supervoid. This idea forms the dipole-repeller model. It reframes the void not as a mystery to be explained, but as part of the explanation for another great mystery, our own motion through space. It is a beautiful, symmetrical idea, but one that carries a deep, existential weight. It personifies the void, giving it agency. It is not merely empty, it is an antagonist. It is a force of anti-creation, actively working against gravity's impulse to build and gather. While gravity forges stars and galaxies from collapsing clouds of gas, the void ensures that vast regions of the universe will remain forever barren and desolate. The fear it engenders is a fear of this cosmic duality. It suggests a universe locked in an eternal struggle between the forces of congregation and the forces of isolation, between being and nothingness. And we are caught in the middle, adrift on a gravitational tide we cannot control, pushed and pulled by unseen giants of attraction and repulsion. The void is the shadow of the great attractor, the darkness that gives the light its form. It is the other, equally powerful, hand of the Creator, the one that unmakes. The human mind has an innate need for order. We seek patterns, we formulate laws, we tell stories to make sense of the vast, chaotic universe we inhabit. The most fundamental of these stories, the cornerstone of modern cosmology, is the cosmological principle. It is a simple yet profound declaration: on the largest scales, the universe is homogeneous and isotropic. It means that no matter where you are and no matter which direction you look, the universe should appear roughly the same. There are no special places, no privileged vantage points. Our corner of the cosmos is no different from any other. This principle has been our guide, our bedrock assumption that allows us to extrapolate from what we see to what we cannot. It gives us the confidence to believe that the laws of physics we measure here on Earth apply everywhere, throughout all of space and time. The cold spot, and the supervoid behind it, threatens to burn that story to the ground. A structure a billion light-years across, so empty and so cold that it defies our standard models, is a direct assault on the cosmological principle. It is not a small, random fluctuation. It is a colossal, unique feature. It suggests that the universe is not the same everywhere. It suggests that there are special places, anomalous regions where the cosmic fabric is different, where events have transpired that have not happened elsewhere. If a structure like the Eridanus supervoid can exist, what else is out there, lurking in the unmapped darkness? Are there voids even larger? Are there regions of space with physics so alien they would be unrecognizable? The void introduces an element of terrifying unpredictability into our cosmic model. It transforms the universe from a well-ordered, if complex, machine into a wild, untamed wilderness, full of exceptions and anomalies. The fear, then, is not of the void itself, but of what it represents, the death of certainty. It is the fear that we are profoundly wrong about the nature of reality. It is the existential dread that comes from realizing that our most fundamental assumption about the universe might be a comforting fiction, a local illusion born of our limited perspective. We are like ancient mariners who believed the world was a flat, predictable plain, only to find a map that shows a gaping hole at its edge, a place where monsters lie. The cold spot is that hole in our map of the cosmos. It forces us to confront the possibility that we do not live in a gentle, uniform cosmos, but in a lumpy one, a place of extremes, with oases of matter like our own separated by deserts of void so vast they challenge the very meaning of the word universe. This is the deepest fear the void inspires. It is the fear of the ultimate unknown, the terror of discovering that the house you thought you knew is built on foundations you do not understand, and that just beyond the walls lies a reality for which you have no name and no laws. Music swells, becoming more profound and reflective. We have journeyed across 138 billion years, from the first light of creation to the deepest chambers of the void. We began with a single, anomalous patch of cold in a sea of ancient light, a simple observation that unraveled our most cherished assumptions. We have chased its explanation through deserts of empty space, into the violent heart of the Big Bang, and across the unimaginable gulf that may separate our universe from another. We have weighed the evidence for a simple void, for a cosmic flaw, for an interuniversal collision, and for a force of cosmic repulsion that actively shapes the heavens. And after all this, the core mystery remains. The cold spot is still too cold. The void behind cluster 14 still holds its secrets close. We do not have a definitive answer. And perhaps that is the most profound lesson of all. The fear that this void inspires is real, but it is also a catalyst. It is the engine of science. It is the darkness that makes us seek the light. The story of the cold spot is a perfect illustration of the scientific process, a mystery observed, a conventional explanation tested and found wanting, and a courageous leap into the realm of new, imaginative, and sometimes terrifying ideas. It reminds us that our knowledge is a small, flickering campfire in an infinite forest, and that the darkness that surrounds us is not empty, but filled with wonders and horrors yet to be discovered. The void teaches us humility. It stands as a silent, billion-light-year-wide monument to our ignorance. It tells us that for all our powerful telescopes and elegant theories, we have barely begun to read the first page of the cosmic story. It is a universe that is not obligated to make sense to us, a reality that will not bend to our expectations. It is wild, strange, and far more grand than our philosophies have dreamt of. The fear of the void is, in the end, a form of reverence. It is the awe we feel when confronted with a power so immense it defies our comprehension. It is the understanding that we are small, fragile beings, adrift in an ocean of mysteries, and that our greatest adventure is the quest to understand even a fraction of it. So we will continue to watch. We will build new telescopes, design new experiments, and stare into that cold, silent darkness, listening for a whisper that might finally tell us what it is. We will continue to face the fear, because on the other side of that fear lies the truth. What would you have done if you could witness it? If you could stand at the edge of that great emptiness and gaze into the heart of a mystery that challenges everything you thought you knew, would you turn away, seeking the comfort of the familiar stars? Or would you stare into the abyss, and let it stare back into you?